welcome back to my class. In the series of learning data structures through C, in the previous video we discussed about bubble sort technique, tracing and program with execution. Well, in today's video we will discuss about one more sorting technique, which is insertion sort. So what is this insertion sort? How the sorting takes place in insertion sort? Let us understand the insertion sort tracing with algorithm. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end. Do not skip the video, and if you like the video, please click on the like button and share the video to all your friends. Insertion sort. The name itself tells you we are going to insert the elements to appropriate positions in the process of sorting. So sorting means arranging the elements in a particular order. So in order to arrange these elements in a particular order, we try to insert the elements at appropriate position. So how do we do that in insertion sort? Let us understand now. So it says, in insertion sort, sorting takes place by inserting a particular element at the appropriate position. We try to insert the element at appropriate positions. How do we do this? Let us understand. And hence the name given insertion sort. So in this technique we try to insert the element at appropriate position. So hence the name insertion sort here. But how do we do that? Let us see that. So in the first iteration, what happens? In the first iteration, the second element, say you have the array like this. In the first iteration, say you have say 5 elements, say in A of 0, A of 1, A of 2, A of 3 and A of 4. Let me write some unsorted elements here. I just say 25, 10, 30 and I just say 7. So some unsorted elements we have. So what we do here, the first iteration when we get into this array elements, the second element which is in A of 1 is compared with the first element which is in A of 0. The second element is compared with the first element. And if it is found to be less, then we do the interchange. So we are going to place it to the proper position. We try to insert the element to the proper position. So we are going to compare these two elements and we try to do the interchange of the positions of those elements. Then, if this is the case in first iteration, where second element is compared with first, in the second iteration what happens? The third element is compared, see in the first iteration we compared the second element which is in A of 1 with the first element which is in A of 0. Second with first. But in the second iteration what we do? We compare the third element which is in A of 2 with the first and second. The third element with the second as well as first. So I can say in every iteration an element is compared with all the elements before it. So look at here. You have this second iteration where the third element is compared with second and first. So we do this at every iteration. So at every iteration, an element is compared with all the before elements. And while comparing, if it is found that the element can be inserted at appropriate position, suitable position, shifting of elements takes place. Just observe here. So this is with second iteration. With third iteration what we do? We compare all the before elements. We compare this fourth element with third, second and first. And if there are any shifting of elements, then we do it. Then again we proceed. In the next iteration, we compare this fifth element with fourth, third, second and third. That's why it says in every iteration An element is compared with all the elements before it. So here what we do, we try to compare with all the before elements and do the shifting of the elements. Let us understand this with a small tracing of this insertion sort. So let us understand the tracing of this insertion sort with this example. So imagine you have the elements like this 40, 15, 30, 5 and 25 unsorted elements. So according to the insertion sort, we have to start the iteration from second element. So obviously we require two loops. So we start the iteration from second element, we have to go up to last. So in the first loop, this is what we need to take care of it. Means the first outer loop, we have to take care of the bound of the loop in such a way that it starts from second element and it moves up to last element. Last element will be in n-1, second element will be in the position 1. So my loop will be from 1 to n-1. So outer loop will be from 1 to n-1. When we get into the inner loop, so we have to maintain two loops, outer loop and inner loop. Any doubts with regarding to loops, you can just check the playlist of C language. You can clear about the nested loop concept in the C playlist. In the inner loop, what we have to do, we have to take care of the loop bound in such a way that it is going to check all the before elements. So I need to check whether it is moving towards all the before elements. So it is up to the element in the location 0. So we need to set the bound from 1 to n-1 for outer loop, and we need to set the bound for the inner loop in such a way that it moves towards all the elements which are before elements which are before it. So I need to reach up to the index 0. So here the second element is compared with first. If it is found to be less, then I need to exchange. So it will be shifted here to the first position. So I need to write it here 15, 40 interchange. Remaining elements as it is 15, 40, 35 and 25. The second iteration, the third element is compared with second and then first. So I am moving towards all the before elements. So the first iteration you will have only one element to compare, but in second iteration you will have two elements to compare because you have two before elements. Second iteration, it has to move up to 0. So index 0, 1, 2, 3 and then 4. Right. Say in the second iteration, the third element is compared with second. If it is found to be less, then do the interchange. Then the second with first. So we will compare this 30 with 40 as well as 50. So 30 has to be placed here. So we are inserting here. So it is 50. Say only this interchange I am going to do. 30 is compared with 40. So it has to be interchanged. So 30 should come here, 40 should go here. Right. Then 30 when compared with 15, I need not interchange. It remains as it is. In every iterations, there may be some exchange. There may not be also. So it is 15 interchange, 30, 40, 5 and 25 remaining elements as it is. The next iteration, I compare this fourth element, that is 5 with 40, with 30 and then 15, where it is found to be less with all these elements, all before elements. Then I need to shift this element, insert this element to the first position. See, look at here. 5, 15, 30 and 40. Right? The next iteration, the last element is compared with 40, I'll do the interchange, 30, I'll do the interchange, 15, no interchange, 5, no interchange. So 25 is placed here. So it is 5, 15, 25, 30 and 40 and finally we got the sorted element. See how easy it is to understand this tracing of insertion sort. Only one thing that what you should know is you have to start the outer loop with second element and you have to go up to last. And the inner loop, you have to proceed in such a way that you check all the before elements. So it is second compared with first. So only one comparison will be there. The next iteration, third is compared with second as well as with first. So all the before elements. The next, the fourth is compared with third, second and first. The fifth is compared with fourth, third, second and first. And finally, we get the sorted list. So this tracing, the tracing of insertion sort, hope you all have understood. So let me have the algorithm of this. And here we have the algorithm of insertion sort. Let us understand one iteration here. So as I said, the outer loop, this is what the outer loop, which is from 1 to n minus 1. And this is what the inner loop, which will go through all the before elements, that is up to 0. So we have two loops. One is outer loop, the other one is inner loop, which is checking with all the before elements. So I equal to 1. I equal to 1 means from second element I am starting up to n minus 1. So it is 1, 2, say n equal to 5. So it is n minus 1 means 4, up to 4. 1 to 4. Then immediately when I enter into this outer loop, I have an initialization which is saying you copy the value of I to j. So j becomes 1. So this is what the I value, this is j value, which is 1. Then I say the inner loop, the j value should be greater than or equal to 1, up to 1. So it is 1 greater than or equal to 1. Yes, condition is true. Okay, so inner loop is true. It is not greater, it is equal to 1. Because I need to decrease here. I am going to minimize the index value. So I say up to 1. So a of j lesser than a of j minus 1. What is a of j? A of j. J means how much? Let me write that value. So this is what the j value. A of 1 lesser than a of j minus 1. That is 1 minus 1, which is a of 0. A of 1 is 15. Is 15 lesser than a of 0? A of 0 means 40. A of 1 is 15, a of 0 is 40. Is 15 lesser than 40? Check the condition. Yes. See, second element compared with first element, the tracing. Just try to understand this with the tracing. Okay. Second element compared with the first element is 15 less than 40. Yes, condition is true. I need to do this swapping code. I am going to interchanges values. I said temp equal to a of j. A of j means 1. A of 1 equal to a of j minus 1, that is 1 minus 1, which is 0. Then a of 0 equal to 10. So what is a of 1? It is 15. I am storing that in temp. What is a of 0? It is 40. Store that in a of 1. Shifting the element, inserting the elements. Whatever I have in a of 0, you place it in a of 1. So a of 0 is having 15. You interchange that. A of 0 is 40. You store that in a of 1. So here comes 40. I am going to overwrite it. But 15 I have already stored in temp. Store that in a of 0. So a of 0, a of 1 you will have 40 and a of 0 you will have 15. So this is what I create space and I do the insertion. That space is nothing but the temporary variable that what we are taking. With the help of temp we are doing the interchanging of the elements. See? So we have interchanged. This is with the first iteration. And inner loop. Here I decrease the value. I say j equal to j minus 1. So it is 0. Get back to this inner loop. So in the inner loop, what happens now? It becomes 0. Is 0 greater than or equal to 1? No. Condition not satisfied. So this inner loop terminates. Control to outer loop. So when I go to outer loop, it gets increased. I need to proceed. I have to come to this up to here. So it becomes 2. So I'm within the bound of 2 to 4. Yes. Again, I need to get inside. Just observe here. In the first iteration, the second element was compared with first. There was only one before element and there was an interchange. We also interchanged and there is no before elements. We have reached up to 0. That's it. So I have to go to the outer loop. Again, I have to start from 2. So now that value will be, so this is the first iteration. Right. The second iteration, j becomes 2. Then I check 2 greater than or equal to 1. Yes, condition true. I need to check a of 2 with a of 1. That is third element with second. So now I need to change all the values. So now let me write a of 2 with a of 1. What is a of 2? It is 30. Is 30 less than 40? Yes, of course. Do the interchange process. A of 1, hope you know the swapping code. A of 1 and A of 2 gets interchanged. A of 1 and A of 2 gets interchanged. A of 1 becomes 30 and A of 2 becomes 40. So 30 is less than 40, do the interchange. A of 1 becomes 30. With the help of temp we did that. A of 2 becomes 40. 30 and 40. Then j gets decreased, j becomes 1. Loop back, inner loop process. 1 greater than or equal to 1. See, I have still one more before element, right? So, third element compared with second, I did that. And also interchange, also we have done it. But there is one more before element. I have to reach up to 0. So, again, inner loop gets executed. 1 greater than or equal to 1, condition true. Now, I need to check a of 1 less than a of 0. Second iteration, we are comparing all the before elements. Third element compared with second, we did this. Interchange also done. But the second element has to be compared with first also, right? So what is a of 1? It is 30. Is 30 less than a of 0? Yes. Is 30 less than a of 0? What is a of 1? It is 30. What is a of 0? It is 15. Is 30 less than 15? No. Condition not satisfied. Swapping code will not be executed. So it remains as it is. Third element compared with second, I did the interchange. Second element compared with first, there is no interchange required. So no swapping, no interchange, no insertion of elements to appropriate position because it is correct. Right. Now decrease the value. J becomes 0. Again inner loop. Then inner loop I say 0 greater than or equal to 1. No. Inner loop terminates. Go to the outer loop. I gets increased. Then I change this to 3. So this goes on. So this iteration we go on. We compare the next element which is the fourth element compared with third, second and first. Fifth element compared with fourth, third, second and first. The remaining iterations is an assignment for you all and we will see this iteration in program in the next video. So hope you have understood with this iteration. You have to do this iteration by yourself. So what all values I wrote here, these iterations you have to do it by yourself. So this is what the tracing of insertion sort. In the next video, we will see the actual program and the complete iteration. So that's all for today's video. See you in the next video. Till then, take care. Bye-bye.